These are the maximum positions we can get it here. Maximum positions we can get it to get maxima here like this. The maximum positions we can get it here if we do so. So secondary maxima, if you want to get it here, another one secondary maxima, which is a very important one. Secondary maxima, if you want to get it, this big secondary maxima, if you want to get it, this intensity should be differentiated. This intensity equation is an I value, I equation is an I square. You can see that I is equals to R square is equals to A square sine alpha by alpha whole square. This equation we have to differentiate to get secondary maxima. So further, if you do it, what happens? Di by d alpha is equals to d by d alpha A square sine alpha by alpha whole square is equal to 0. So differentiation of di by d alpha should be equal to 0. Then only will get maximum intensity. The condition. Here is given that in between the minima we get secondary maxima. So the position can be obtained by differentiating I with respect to alpha, equating to 0, we get a secondary maxima. So if I differentiate this one, then d by d alpha A square sine alpha by alpha square is equal to 0. By differentiating the A square, the square as it is, sine square alpha by alpha is there. This sine square alpha means it is square, sine alpha differentiate 2 sine alpha by alpha. Whole square is not, but whole square we are differentiating, so 2 sine alpha by alpha. Sine square alpha can be written as here. This sine square alpha in differentiation is A cos alpha, means first u by v method. First sine alpha differentiation cos alpha. Already alpha v as it is alpha we have written here, minus u by v method. Remember this. So next time sine is going to be constant, but this we have to differentiate. So alpha differentiation 1, so 1 sine alpha as it is we have written by alpha is equal to 0. Either sine alpha is equal to 0. In this equation, if I totally do it, this becomes 0 if I send this side. This also becomes 0 when I send this side. Then remains A cos alpha minus sine alpha by alpha square is equal to 0. The cross multiplication, if you do it, it also gets cancelled. So it also becomes 0. So A cos alpha minus sine alpha is equal to 0. That remains. So either this value should be equal to 0 or this value should be equal to 0 to get total 0. So A cos alpha plus minus sine alpha is equal to 0. So hence the position of the secondary maxima are given. A cos alpha minus sine alpha. A cos alpha minus sine alpha is equal to 0. If I send this sine alpha this side, alpha is equals to A cos alpha is equal to sine alpha. Then A is equal to tan alpha, like this you can get it. So the values of satisfying the above equation, the values satisfying the above equations are obtained graphically by plotting the curve between tan alpha and alpha. Tan alpha and alpha, if you draw the graph, on y-axis tan alpha is taken, on x-axis alpha is taken. So here we are getting curves like this for tan. So pi by a 0 we have, the curve is like this, and pi by a minus pi by a. So again the curve is intersecting at this point, so minus pi by a. The curve again intersect the point of y. So here it is getting again like this we are getting. So here so you can write here. So alpha is from this one, alpha is equal to 0, 0 minus pi by a. Here this is over 0 now. Here the curve is touching that intersecting point. Now it is the pi by a. It is 3 pi by a, 5 pi by a, like that it is there. Substituting the values in equation 1. So alpha is equal to 0. Alpha is equal to 0. This alpha is equal to 0 if I write I naught is equal to a square. So if I substitute here in this equation, alpha is equal to 0. Here I can get it. Okay, here. So if I substitute alpha is equal to 3 pi by 2, then I1 is equals to a square sine 3 alpha value 3 pi by 2 by 3 pi by 2. So nearly equals to a by 27, first secondary maxima. So again alpha is equal to 5 pi by 2, if I write I is equals to a square sine 5 pi by 2, 5 pi by 2, 5 pi by 2 whole square. It's another maxima, secondary maxima, and so on. It is happening because here we are taking these points, this one point and this one point. Here the some point is coming here and here, and like this it is getting the curve. This diagram you have to write in examination definitely. So whether you are writing like this or this one or not, but even though you should write the diagram definitely, and you should say some of these values enough. Okay. So intensity distribution will be like this. Here 0, minus pi, n pi we are getting now for maximum. So pi, 2 pi, 3 pi minimum are there. So between 0, minus pi to 2 pi we are getting one maxima. That is 3 pi by 2. Again here we are getting maxima 2 pi to 3 pi, 5 pi by 2 is here we are getting maxima. Here 0 to pi, this is already maxima. Pi to 3 pi, pi to 2 pi, we are getting in between that 2, 3 pi by 2, here maxima. 2 pi to 3 pi, in between that 5 pi by 2, maxima like this. If I draw graph between the alpha and I intensity. So this is about the topic of diffraction by single slit, Randolph diffraction by single slit.